Hi, good morning everyone. So today our group will present about calcium in soil and plant. I am Elizabeth Yusun Albert as the first presenter and the second presenter is Christina Bulan. Third presenter is Darfini Tambo. Fourth presenter is Dorina and the last presenter is Daryl Melvin. What is calcium cycle? The calcium cycle is a transfer of calcium between dissolved and solid phases. There is a continuous supply of calcium ion into waterways from rocks, organisms, and soil. Calcium magnesium occurs in the soil a soluble divalent which is a double charged cation Ca2 plus and Mg2 plus on cations exchange sites and mineral forms. Calcium exists in equilibriums with the soil solutions, replenishing soluble calcium losses by plant uptake or leachings. In addition to the dissolutions of these secondary deposits, calcium is also released through the weatherings of primary minerals such as feldspars, micas, and limestones. Calcium-magnesium dynamics in the soils are quite similar to potassium. Plants absorb the soluble ionic form from soil solutions which is replenished by exchangeables and mineral calcium magnesiums. The most notable difference between this nutrient cycle is the absence of calcium magnesium clarifications.
Hi, my name is Christina Bulasadin. Now I will explain about the form of calcium in soil. In acid, humid region soils, Ca2 plus and Al plus 3 dominate the CEC. Next, the exchangeable and solution of Ca2 plus are in dynamic equilibrium and plant available form. The most important factor in determining Ca plus 2 availability to plants are total Ca supply, soil pH, CEC, the percentage of Ca plus 2 saturation on CEC, type of soil clay, and the last one is ratio of solution Ca plus 2 to the other cation. Calcium is also present in soil as it varies from mineral particle, CaCO3, simple salt, and exchangeable Ca. Mineral particle. Calcium is mainly present as primary minerals such as basic plagioclase rich in anorthite, epidote, basalt, and diabase. On weathering, all these minerals release calcium in the soil. Second is CaCO3. The nodular form of CaCO3 and even amorphous CaCO3 exists in the soil. Third is salt. Calcium is also present as its simple salt like CaCl2, CaSO4, CaNO3, Ca(HCO3)2, and the other salt in the soil. And the last one is exchangeable Ca. Among various cations, calcium is the dominant exchangeable cation present on the soil exchange complex.
Hello, my name is Darfini Dambok from 3A, Group 4. Large addition of Ca inputs such as lime or gypsum may be recommended to address soil pH and solidity problems. If soil pH is adjusted to above 5.5 or ESP reduced below 5%, calcium is unlikely to be in low supply. When target input are needed during the growing season, several highly soluble Ca sources are available. For limes, is about 40% of calcium should be used on acid soils at rates to adjust the soil pH to the target level. Typical rates are 2.5 to 7.5 ton per hectare, and a lime requirement test will assist in identifying an appropriate rate. In cropping system, lime should be applied several months ahead of planting and mechanically incorporate. Lime will not dissolve in alkaline soil, so should not be considered as a calcium source in those situations. For gypsum, about 23 of calcium percent is used as a calcium supplement and as a soil ameliorant. When used, surface applied gypsum needs to be applied well ahead of planting. Phosphate fertilizer contain quite large amount of calcium, which is single superphosphate has 20% of calcium, while triple superphosphate has 15 calcium. There is very little calcium in MAP or DAP. For foliar sources such as calcium nitrate that has 19% of calcium, calcium ammonium nitrate that has 10% of calcium, and chelate calcium can be beneficial to address potential deficiencies, but only a limited amount of calcium that can be assimilated this way. However, a foliar application near the tissue can reduce the risk of the effect of calcium deficiency.
Hi, my name is Dorina Anadao from AT2203A Group 4. I will present about calcium in plant. An important nutrient for plant is calcium. As the divalent cation Ca2+, it is necessary for structure function in the cell wall and membrane as a counter cation for inorganic and organic anion in a vacuole as an intracellular messenger in the cytosol. The xylem transports calcium from the soil solution to the roots and then to the shoot. It can move via the cytoplasm of cell connected by plasmodesmata, the cytoplasm, or the gap between cells to go through the root, the apoplasm. It is uncertain how much the apoplastic and symplastic pathway contributed to the transfer of calcium to the xylem. To allow root cell to signal using cytosolic Ca2+ concentrated, regulated the rate of Ca supply to the xylem and avoid the build-up of poisonous cation in the shoot. The transport of Ca across various channels must be carefully managed. The cellular absorption and transduction of the Ca2+ signal are made possible by proteins such calmodulin, calcineurin B-like protein, and Ca2+ dependent protein kinases, which alter their conformation or catalytic activity upon binding Ca2+. Okay, next I will present about the form calcium in plant. Plant cell walls are large constructed with the help of calcium, namely calcium pectate. When calcium levels are low, abnormal cell wall production frequently occurs in new tissues such as root tips, young leaf, and shoot tip, which distorted the appearance of new development. Additionally, calcium is involved in signaling processes that coordinate specific cellular activities and activating specific enzymes.
Calcium transport in plant. Calcium transport pathway from root to shoot is transported through the cytoplasm or intercellular space of cell connected by plasmodesmata. This involves calcium uptake by root cell, transport from root cortex to xylem, and calcium will transport to leaf and fruits. Calcium channels, antiporters, and calcium ATPase play a role in calcium uptake and transport in root cell. In order to be transported from the root surface to the xylem, calcium must pass through xylem, endoderm, and parenchymal cells. The endodermal cuspary zone, the major barrier to apoplastic movement of iron to the stele, allows some calcium to enter the root symplast via calcium channel in endodermal cell and enter the xylem, reach the soft tissue. Calcium actiphase can drive calcium from the xylem parenchyma to the stellate apoplast. Some calcium is exflux with endoderm cells and migrate to the xylem via the apoplastic pathway. Calcium is transported to the plant xylem reservoir in a chelated form, and the rate of water flux is an important factor in calcium transport across the stem xylem. Both apoplastic and sympaplastic pathway of calcium transport are also present in fruit or leaf tissue. Okay, next, calcium function in plant. Calcium is essential for plant division and elongation, therefore deficiency symptom primarily exhibited in meristematic region of rapid cell division. So basically it is for plant growth. Okay, low calcium uptake combined with limited translocation of carbohydrate causes distinct symptom in fruit and vegetable crops. As you can see, this is the deficiency system of calcium. The leaf tip and margin are chlorotic, which is becoming a little bit yellowish. Failure of terminal buds of shoot and apical tips of root to develop, causing plant growth to cease. Toxicity calcium in plant. Too much calcium in the oil can make it harder for plant to absorb magnesium, potassium, phosphorus, copper, zinc, iron, and boron. Other than that, cloudiness or residue in the water you are using to grow your plant, especially in hydroponic system,